We want to find the exact area enclosed between the curve y is x minus 1, x minus 5 take 1, the x-axis, and the lines x equals 1 and x equals 5. So I'm going to go to graph and table. Let's just clear anything I've got there at the moment. And y is x minus 1, x minus 5, take away 1, and let's graph that. So slightly better axes might work here. So let's go from 0 to say 6 and go minus 10 and 10 or something. And then we get a much better picture. And we can see from 1 to 5 the whole area that we're interested in is below the axis, so we haven't really got a problem there. And we can integrate just here if we want to, but I'm just going to go back to main and do the integral. So we have got the integral from 1 to 5 of, let's just put some brackets down, so bracket, nope, I've put the brackets in the wrong place, so always be careful. So bracket, x minus 1, open a bracket, x minus 5, take away 1, close the bracket, and that one is dx. And that's, I'm going to go to standard actually, and let's do that again, negative 44 over 3. So I'm going to write down the integral that I've done, 1 to 5, x minus 1, x minus 5, take away 1, and that gives me negative 44 over 3. So therefore I know for 44 over 3 square units is what we want. The negative is just because it's below. Now we want to use the trapezium rule. So if I go back to my graph and table, and here I'm just going to table instead, and let's just change that so that we go from 1 to 5 with a step of 1, and then we can see that our x values are 1, 2, 3, 4, 5, so that will give us the 4 strips, 1 to 2, 2 to 3, and so on. The y values, negative 1, negative 4, negative 5, negative 4, negative 1. So trapezium rule is going to be a half, so the first and last y, negative 1 take 1, and then twice all of the other ones, so negative 4, negative 5, negative 4. So what's that giving me? Negative 2. This is negative 13 times 2, take away 26. So that's negative 28 over 2, which is negative 14. So that's going to be 14 square units. And then we want the percentage error. So let's go back to main. Now we can use a modulus here, and we can do the 44 over 3 take away 14, so that will give me the actual error. Now what I want to do is divide that by the exact value, which we know was 44 over 3, and then to turn it into a percentage we'll just multiply by 100, and that's 50 over 11, which is 4.5% approximately. Now we want the same estimate using Simpson's rule. So this time it's the h over 3, h here is 1 because the steps are 1. And then we know negative 1, negative 1, so that's the first and the last values. And then we have twice the odd numbered ordinate, so that's the third one here. and then 4 times the even ordinates, which is going to be those two, like so. So that's going to be 1/3. So what have we got? -2, take away 10, so take away 32, which is -44/3. So that's 44/3 square units. Now, why is Simpson's rule completely accurate in this situation? Simpson's rule uses a parabola to go between the ordinates. We know with the trapezium rule you get a straight line, but Simpson's rule uses a parabola, and since the original curve was a parabola, it's going to match it exactly.